Water. Water is essential for humans. Water gives life to crops. Water boosts our hygiene and addresses our cleanliness needs. Developing countries use an average of 130 liters of water every day. Do you know what happens to all this water we use? 70% of it goes to the drain after being consumed by us, after which it goes to the STPs for treatment, and a portion of water is reused. It is reused for secondary use in industrial processes, washing cars, or even refilling aquifers. That sounds great. But wait, that is not the complete picture. Sewage treatment plants use various processes to clean the sewage water to make it usable for secondary reuse. But where do all solids go during this process to make the secondary water clear? Sludge, the nasty byproduct of the STP process. Sludge contains organic matter, pathogens, toxic chemicals, pharma-active compounds, heavy metals, microplastics, and inert matter. Where do all these contaminants come from? These contaminants come from all the chemicals we use in our daily use products, cosmetics, and industrial waste. In most developing countries, we do not have separate sewer networks for these products. Even the industries do not have operational zero liquid discharge plants. These contaminants also come from all the garbage that runs off into sewer systems or leaches into the ground during rains. How do we generate all these contaminants? What is the source of all these contaminants? Household liquid waste, coming from chemical agents, bathing soaps, and cosmetics. Commercial liquid waste, chemicals, oils, dyes from small businesses. Medical waste, industrial liquid waste, human and animal feces. What is biological sludge and how badly it is managed and disposed of? Sludge coming out of STPs are a health hazard, creating problems like infections and odor. Disposal issues leading to groundwater contamination, toxic runoff to water bodies, and release of greenhouse gases when dumped in the open. But we consider sludge as cultured biosolids because we know that the composition of microbial cell is 50% carbon. This carbon can be used as a fuel source to run a system. Let's look at the calorific scale and where different kinds of sludge sits. Raw sludge, around 4,000 kilocalories per kg. Biological sludge, 4,200 to 5,500 kilocalories per kg. Poorly digested sludge, 3,200 to 3,700 kilocalories per kg. Well-digested sludge, 2,200 to 2,700 kilocalories per kg. Very well-digested sludge, around 1,100 kilocalories per kg. In most real-world scenarios in the STP process with digesters, the sludge calorific value ranges between 1,700 to 2,500 kilocalories per kg, depending on the efficiencies of the digesters. Sludge treatment process. The aerobic sludge is at 1.5% dry solid consistency. At this stage, it's mostly liquid. At the thickening stage, the consistency of dry solids in the sludge is brought up to 5 to 6%. Here, the non-bonded water is removed. At the dewatering stage, the bonded and capillary waste is removed to bring the solid consistency of the sludge to 18 to 22% dry solids. This is generally done at the end of the current sludge treatment process, after which the sludge is put on drying beds to dry and then transported away to be dumped. This is where SSP's THESVORES technology comes in. THESVORES stands for Thermal Stabilization and Volume Reduction of Sludge. THESVORES takes the 18 to 22% dry solid sludge from the dewatering stage and then dries it at around 250 degrees Celsius to remove the water at the cellular level. After this stage, the sludge is 92 to 95% dry and it's now like a free-flowing hot powder. This 95% dry solid sludge is high in calorific value. We use this dry powder as a fuel in THESVORES to dry the sludge. As the sludge is used up as fuel, It is reduced in volume, and all we are left with is inert solids which are like a fine powder. For example, if we have 1000 kg of 18 to 22% dry sludge, after the drying stage we are left with around 220 kg of 92 to 95% dry sludge, which after the volume reduction stage is left with only around 100 kg of inert material, effectively reducing the total volume by 90%. What can the inert solids be used for? To make non-load bearing tiles, river embankment, concrete railings and poles, etc., getting a strength of M20 and more. SSP, a sustainable solution provider.